There's also a lot of hope that new technologies can do a better job of sensing and communicating between different road users to improve safety. Intersection safety is a really important topic. Nationwide, 50% of serious crashes occur at intersections, and that accounts for 25% of total traffic fatalities. Deaths from red light running are also on the rise. Now, reducing these numbers requires an array of strategies, from engineering countermeasures to education to enforcement. There's also a lot of hope that new technologies can do a better job of sensing and communicating between different road users to improve safety. The traditional way of evaluating safety at intersections is to look at collision data, which can provide a lot of really useful detail on exactly how collisions are happening at intersections. But the issue with using this as your main data source is, by nature, it's reactive. You have to wait for collisions to happen before you can start to see a pattern and take measures to address it. So it's important to think about what data sets are available that can help us to be more proactive about finding issues at intersections and addressing them before they result in collisions. SPM can be a piece of the puzzle at tackling intersection safety, so let's look at where it fits in. I'm going to draw an intersection. Now, the primary way of using SPM for a safety application requires a special set of detectors that are actually upstream of the stop bar and located inside the intersection. What detectors here can do is, let's say we have our platoon of vehicles that's about to arrive into the intersection. These will be detected at these detectors, and we can combine this detector data with what's happening at the signal to know, for example, that these vehicles arrived on green, these vehicles arrived on yellow, particularly that these vehicles arrived late in the yellow, and that these vehicles actually entered the intersection once the light was already red. SPM can tell you where you have intersections or approaches or times of day where a lot of vehicles are arriving into the intersection late on the yellow or into the red. And if you see that, there's a number of operational strategies that you can pursue to mitigate the issue. One is evaluating your yellow and red clearance intervals. If the yellow clearance interval is too short, vehicles run the risk of running red. If it's too long, vehicles get used to that long yellow and they treat it more as an extended green. You can also look into your dilemma zones. So dilemma zones are that location before the intersection where, as a driver, you're unsure if the light turns yellow, whether you should brake or should continue through the intersection. If you put detectors in your dilemma zone, you can use them to extend the green when a vehicle's approaching on yellow so that they make it through. You can also look at your cycle lengths. If a cycle length is made longer, that's fewer opportunities that the signal is turning red, fewer opportunities for red light running. But at the same time, if a cycle length is too long, cars start to know that when they hit a red, they have to wait for a long time. So it might incentivize them to run the red. And lastly, you can look at improving your coordination, because when more cars are arriving on green, that's less chance for red light running.